Dear students, grade 12, this is the second video of revising Equilibria. Let's start. In the previous video, we again revised the meaning of the water ionization, the water ionization equation and the Ka. And here, a common way to express the acidity and basicity with the pH. How to calculate the pH using the hydrogen or the hydronium, or using the hydroxyl or the concentration of hydroxyl group. So the pH equals minus log of the concentration of hydrogen or concentration of hydronium ion. Okay, in neutral solution, we said that the concentration of hydrogen is equal to the concentration of hydroxyl, and both of them are equal 1 times 10 power of minus 7 at 25 degrees Celsius. And if you take the minus logarithm of any of them, the pH will be 7, and this is neutral. Okay, now here is one question. What is the pH of the 0.0010 molar of NaOH, sodium hydroxide solution? So in here, this is a base, so you're having the concentration of OH, and sodium hydroxide actually is a strong base. Strong base and strong acids, remember we said that strong bases and strong acids, they completely ionize or completely dissociate in water. So if you want to calculate the pH and you have a base, all you have to do is calculate the concentration of OH, right? So this is the concentration, because this is a strong base, so this is the concentration of the hydroxide, right? And we said that H or hydronium times OH, the concentration equal 1 times 10 power of minus 14, right? So if you're having that, which is this, so hydrogen times 0.0010 equal 10 minus 14. So the concentration of hydrogen here equals 1 times 10 power of minus 14 divided by 0.001 gives us the concentration of hydrogen, which is that. And then you take the minus logarithm, and this gives you 11. As a general conclusion, if the pH equals 7, this means that the solution is neutral. If the pH is more than 7, it's basic. If the pH is less than 7, this means that it's acidic. If the pH of Coke is 3.12, what is the concentration of hydrogen? Right? Okay, so because the pH equal the negative logarithm of concentration of hydronium or hydrogen. Here you have the pH, right? And you need to learn that, right? So the concentration of hydrogen is simple. Just 10 by minus 10 the pH. Power of the pH, sorry, the H should be capital. There it is. Taking the anti-log to get there, minus pH. The concentration of hydrogen equal 10 power of minus pH. So to calculate the concentration of hydrogen for that, there, equals 10 power of minus 3.12. And let's check here. Equals 7.6 times 10 power of minus 4 molar. I think this is easy, right? Okay, px equals minus log, like the pH, right? POH also equal minus log concentration of hydrogen. This is just Kw equal concentration of hydrogen times the concentration of the OH. Take log for both sides. There. Minus log 10 power of minus 14 equals minus log, because multiplying in logarithm means adding, right? So the pH and the POH equals 14. When you add them, they are equal 14. This is just an information. Okay, the Ka of acetic acid is 1.8 times 10 power of minus 5. What is the pKa? Do you remember what do we mean by pKa? The pKa is minus log of the pH, right? Okay, how can you solve that? Let's try. There. The pKa equals the minus log of Ka. So it's simple. Just equal minus log, and you have the value. Just substitute. Equals 4.74. And to remember also, it doesn't have unit. The pKa does not have unit. Okay? Now, the pH. This is a small diagram showing you the pH. The concentration of OH when you're going from 7 to 14, and the concentration of hydrogen from 7 going towards 0. The pH, the POH scales. Okay, we said that both of them multiplying the concentration of hydrogens times the concentration of hydroxyl is a constant, 1 times 10 power of minus 14. So if you're having the concentration of hydrogen is 1 times 1 there, the pH is 0 and the POH is 14. And as you can see, going on means both of them, when you multiply them, the concentration of hydrogen and concentration of hydroxide, both of them are always equal. Multiplying them, or the product of them, always equal 10 to the power of minus 14. So for example, if the concentration of hydrogen is 1 times 10 power of minus 3, so here is minus 11. So the pH is 3, the POH is 11, right? Here is another question. Calculate the concentration of hydrogen, pH, concentration of hydroxyl, and the POH for 0.02 molar of nitric acid, right? So is a nitric acid strong or weak? Let's check. Nitric acid is a strong acid. So because it's a strong acid, it will completely ionize. So the concentration of hydrogen will be the same concentration as its acid, because it's a strong acid. Okay? So to calculate the concentration, here's the concentration, of course, because it's the same concentration of hydrogen, and calculating the pH, which is equal minus log the concentration of hydrogen. So the pH is 1.7. Okay. So the pH is 1.7, right? And we said the concentration of hydrogen times the concentration of hydroxide equal 1 times 10 power of minus 14. So you have this and you have that, which is 2 times 10 power of minus 2. So the concentration of hydroxyl divide 1 times 10 power of minus 14 divided by 2 times 10 power of minus 2 gives you 5 times 10 power of minus 13, which is the concentration of hydroxyl, POH. That will give you the pOH just by taking the minus logarithm. These are pH examples. This one shows the acidity, and if you go up, this is more basic, and if you go down, this is more acidic as you go up and more basic as you go down. These are actually examples from things we use or things we have. This is the gastric. Gastric means the acid in your stomach, right? The acids in your body, humans, which is very acidic. The pH range from 1.6 to 3. Soft drinks, also very acidic. It has carbonic acid from 2 to 4. Lemons, vinegar, tomatoes, beer, urine, milk, saliva is acidic also, right? But it's weak acids. Blood, plasma, egg white, milk of magnesia, which is basic. They use it to treat the heartburn. And the household ammonia, the detergent you use in your house. Now, the ionization constant for weak acids. Okay, weak acids, the Kc, which is the constant dissociation of weak acids, equal the concentration of hydrogen times the concentration or the products divided by the reactants. And in reactants, of course, we don't use the water, we use the molecule of the acid before dissociation. Write the equation for the ionization of weak acid, HCN, and the expression for that. There. HCN, right, gives hydrogen plus Cn. And the Kc equals the products divided by that. So it's H times Cn divided by the concentration of HCN. There. Okay. And here, equilibria involving weak acids and bases. Do you remember the acid and the conjugate base, the base and conjugate acid? Yeah. Okay, consider acetic acid, HOAC, which is an acid because you have an H plus H2O gives 3/4 of hydronium and OCA, which is the conjugate base. If you calculate the Ka, you need the products divided by the reactant. There. So the K is designated Ka for acid, weak acid, because the concentration of hydrogen and the conjugate base are small, which is smaller than 1. That's considered weak acid. This is one homework you have, okay, for the revision of that part. Happy Ramadan for all of you, and hope you're staying safe, and seeing you soon.